Okay, class, it's time for some pre-calculus, so bear with me because we're going to do chapter 10.3, which is arithmetic and geometric sequences. So here we go. Let's check it out. It says, pre-calc 10.3, page 504, arithmetic and geometric sequences. So first thing we're going to learn about is compound interest, which we've talked about before. And this is the formula that you're normally going to see for compound interest. Okay, the amount of interest you're going to get, amount total, is going to be the principal times 1 plus the rate to the time power there. But this is a more better equation. It's more advanced, and you guys are really advanced, so we're going to throw this one to you. Same equation, but n refers to the amount of times that you're going to be getting your compound interest. So, you know, sometimes you might get it quarterly, or sometimes you might get it like monthly. You know, so if you're going to get it quarterly, that means that you're going to get it 4 times per year. So you put in 4. If you're going to get it monthly, you'd put in 12. Okay? Let's keep on going. So back to my equation. So we're going to put in here n. It's just a little extra if you're getting compound interest more than once a year. So let's check out example 1, page 504. It says, find the interest earned on $100 if it's earning 6% annually for 10 years. Boom, 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 boom. Compounded quarterly. Okay, that means we're going to plug in a 4. So there's my equation. Oh my, by golly. There's my equation, but I'm going to be plugging in 100 because I'm going to plug in $100. That's my principal. It just means cash. Putting in $100 cash. My rate is 6%, so I'm putting in 0.06. And then my time is 10 because it's 10 years. I'm going to do it for 10 years. But my n value is 4 because I'm compounding it quarterly. That means 4 times a year. Okay, let's keep going. Okay, so when you plug all that stuff in, you get this equation here. And you're going to do 0.06, my 6% divided by 4. And you're going to get 0.015. It's going to be to the 40th power because you're multiplying it by the 4 times 10. And when you do that, of course, you do the 1.05 to the 40th power first. And then you multiply it by 100. And when you do so, you get $181.40. Well, that's how much money you'd have in your account. You see, you started with putting in 100. Now you have 181, right? So the question is, what's the interest? Well, you ended up with 181. You started with 100. That's $81.40 in interest. Boom! Let's keep going. Okay. Next one, arithmetic sequence. Arithmetic sequence, that's the equation for an arithmetic sequence. You guys have done this one before. The nth term, a sub n, is the first term plus n minus 1 times d, the common difference. That means if it's going up, arithmetic means like you're adding or subtracting. If it's going to go up by 5, you'd be like, that would be 5, right? If it's going to go arithmetically up by 5, right? So there you go. So my equation, if I distribute that, d times n would be nd, and then d times a negative 1 would be negative 1d. I just distributed it. No biggie, no biggie. Now, if I took my a sub 1 and my negative 1 times d, and I could put those together, I just grouped them. I'm not changing the equation. I'm not changing the equation. Just chill out. I'm just going to group them. Okay, here we go. So I'm going to take my a sub 1 and my negative 1d. I'm going to group it right here. A sub 1 take away d. That's just negative 1 times d, just negative d, right? And then I have my n times d right here. Remember, d is the common difference, right? So what we do here is I'm just going to label a sub 1 take away d as just a letter c. It's just some number that's going to be whatever that is, right? And n times d ends up being where my common difference kind of shows up, right? So if you look here, my common difference of a 5, if my common difference is 5, if it's going up by 5 each time, then I would have 5 times n, which would be 5n. So my common difference would be 5 times n. This is going to be like a sweet form of my a sub n. A sub n is 5 times n plus 4. It's just a way of looking at your arithmetic sequence. Your arithmetic sequence there a little bit cleaner. And when you have that in the form of we have something times n, that something is your common difference. It's the common difference. So we know it's going to be going up by 5. It's kind of like my slope, right? Okay, moving on. Let's check it out. So if I take that, that's an arithmetic sequence. This is example number 2, page 505. Is that an arithmetic sequence? Yeah, because that's the one we just did. Okay, you guys are with me. So yes, that's an arithmetic sequence with a common difference of 5. Okay? B, is that an arithmetic sequence? Yes, it is. What's the number in front of my n? It's a negative 1 over 2, negative 1/2. So it's an arithmetic form with a common difference of a negative 1/2. So that's okay, like my slope would be a negative 1/2. That's all good. But is this an arithmetic sequence? No, it's not, because it's not a regular old n value. Look, okay, that would be n to the 1/2 value, a square root. That's no good. N to the 1/2 value, a power, that's not the right kind of n. That doesn't fit with our arithmetic sequence. Not a regular n value. The coefficient in front of the n's doesn't have it. This is all just messed up. It's poo-poo. Not an arithmetic sequence. Let's keep it going. So then, is this an arithmetic sequence? No, because look it, that's not a regular old n value. Now I got n squared. Look, I want n. I want n. I don't want square root of n, and I don't want an n squared. So that's not, because it's got n squared instead of n. It's not arithmetic at all. Come on, people. We don't want those. We want arithmetic. Okay, let's keep it going. Example 3. Now we're going to be dealing on page 505, and we're going to be trying to find a sub n and also a sub 10, a specific point, specific term in our sequence. Let's try it. Okay, here we go. So example 3, page 505 says, find a sub n if we know our starting point is the square root of 5, and we know our common difference that we're going to go up each time is the square root of 7. So we're starting at the square root of 5, and we're just going to add up the square root of 7 here. So we plug it into our original kind of default equation up here, my a sub 1, that's going to go in as the square root of 5. Boom! I did it. Okay, then my letter for D is the square root of 7, so I'll plug in the square root of 7. Boom! I did it. There's my equation. Right? If I multiply it all out, I could get a more cleaner cut one, but I don't need to because I just want to find a sub 10. What would be my 10th term? Well, plug in 10 right there. Oh, that's really, really unfocused. Oh, that's much better. That right there, plug in 10 right there. 10 take away 1. Okay, I know we're in pre-calc. You guys get this. 10 take away 1 is just 9, okay? You guys got that. Okay, let's keep it going. So if I plug in a 10 right there for my 10th term, if n is 10, my 10th term would be 10 take away 1. That'd be 9 times the square root of 7. So I've got my original term, a sub 1, and then 9 times the square root of 7. Ba-boom, that's my 10th term. Sweet. Well, we've done a lot of arithmetic. Let's deal with some geometric. Geometric just deals with a common ratio rather than a common difference. Okay, check it out. Find a sub n if it's geometric, and we know it starts at 12 and has a common ratio of 2. Now, if you went back to the last lesson as we did, that right there is the equation for a geometric sequence. My a sub n is just my first term times my ratio to that power, common ratio to that power. That's the geometric formula. We know we're dealing in that form. So plug it in. My first term is 12. They told us that right there. And then my ratio, my common ratio, r, is 2. So I plugged in 2 right there. So don't multiply those together till you take your power. You guys are both PEMDAS, people. Right? So what I'm going to do here is do 2 to the n and 2 to the negative 1. That's what I wrote down here. 2 to the n and 2 to the negative 1. Just to make it a little simpler, right? Kind of spread it out. But 2 to the negative 1, when you have a negative power, you got to drop that down below, right? Negative powers go to the denominator and turn positive, okay? So that'd be 2 to the first if I could drop it down like that. Just drop it down below, it becomes 2 to the first. 2 to the first is just 2. So 12 over just 2, 12 over 2, that's just, wowzers, it's windy. Goodness. 12 over 2, that's just 6. So I really just have 6 times 2 to the n, right? That 12 over 2 just cancels. 12 over 2 cancels. I just get 6 times 2 to the n. So if I want to know my 10th term, I just plug in 10 right there, 2 to the 10th. So it'd be 6 times 2 to the 10th, right? 6 times 2 to the 10th. Well, 2 to the 10th is 1,024. Don't you dare. Don't you dare multiply that first. Don't you dare do that first. You got to use PEMDAS. Do exponents first, then you could do multiply, okay? 2 to the 10th first. 2 to the 10th first, that's 1,024. And then 6 times 1,024 is 6,144. That would be your 8 to the 10th, 8 sub 10. What? We already done? We done! That was some fun stuff. You guys got this. Have fun on the homework. Lend it out.